Hello, today I'm going to present the visualization. Here we're going to study the 5 different sorting techniques. The first is bubble sort. Bubble sort is a simple algorithm. It compares adjacent elements in the list, and if the first element greater than the second, it swaps them. In this way, for each pass, the current biggest element comes to its final position. Here is the algorithm below, and here is the pictorial representation of the bubble sort. Second, insertion sort. Insertion sort takes place element one by one and insert them in the correct position into a new sorted list. Insertion works efficiently for a small and almost sorted list. Here is the pictorial representation of insertion sort. Selection sort. Selection sort is another basic sorting algorithm. Selection sort finds the current minimum value and swap it with the current file element of the list. The selection sort representation. Merge sort. Merge sort algorithm uses divide and conquer strategy to sort an array of elements. Merge sort algorithm performs in two phases. The first phase algorithm splits array into two equal length of subarrays, and the process recursively continues on the subarray until there is only one element in the subarray. In the phase 2, the merging process takes place, and that will take two sorted subarrays of A and merge them into a single sorted subarray of A. Here's the algorithm and the merge sort. That's the first phase, split phase, and that is the merge sort, merge phase. Then fifth algorithm, the last, quick sort. It is a sorting technique that sequences a list continues by dividing the list into two parts and moving the lower item to one side and the higher item to the other side. It starts by picking one item in the entire list to serve as a pivot point. All the items that compares lower than the pivot are moved to the left of the pivot, and equal or higher items move right to the. It then picks a pivot for left side and moves those items to the left, the right of the pivot, and continues the pivot picking and dividing until there is only one item left in the group. It then proceeds to the right side and performs the same operation again. Here's the algorithm, and here's the representation of, and here the 9 is the pivot, 4 is pivot, 25 and 40 is the pivot. Now we are using 4 datasets. The first synthetic, second synthetic. We use the random number generator for generating the synthetic datasets, and the real dataset we are using the data. The first is the number of daily births in Quebec, and the second is monthly mean discharge in cubic meters per second from the Niagara River at the Keystone. Here is the time and data size graphs for dataset synthetic dataset 1. Memory versus data size, time versus sortedness, memory versus sortedness, time versus data size, memory versus data size, time versus sortedness, memory versus sortedness, time versus data size, memory versus data size, time versus sortedness, memory versus sortedness, time versus data size, memory versus data size, time versus sortedness, and memory versus sortedness. For visualization, we are using R programming language using the tool RStudio. We are taking two real data sets with a data size of 100, and their visualization are as follows. conclusion. So, merge sort is the best of all sorting algorithms, followed by quicksort because both have the better time complexity than the remaining sorting algorithms. Insertion sort can be used when the data size is not large and almost sorted. The bubble sort and the selection sort have the worst performance, especially bubble sort having the most inefficient performance.